Johnjoe, you have a great approach of addressing the problems of consciousness. You go through the why, the how, the why not, the what, the where. So these are talking about the heart problem, the binding problem, um, what what is the difference between conscious and unconscious brain processes, where is the seat of consciousness. So I'd like you to start this conversation by running us through these processes, and in doing so, I'd also appreciate if you could talk me through your views on all of this prior to your quantum biology revolution, because it's always interesting to see how someone's view changes over time as well regarding these
Okay,
familiar concepts.
okay. So first, why are we interested in consciousness? Um, because if you go to the butcher shop and you look at a brain from a cow, it just looks like meat. That's what our brain would look like, a lump of meat. And the strangest thing in the universe, in my view, is the fact that a lump of meat can know it's there. And that to me is profoundly puzzling and strange because nothing else outside of that lump of meat inside our heads and presumably other people's or other animals' head has this property of knowing itself, knowing that it is around, that it is a thing. And and that property is kind of mysterious because it's outside of science. Science does not talk about this. It's not an area that can ever look inside our heads and describe our experience. It's only a first person account that we can ever give of our experience. And yet it's the most important part of us. It's what would life be like if we were totally as zombies, as the conscious community tends to call it. If we were zombies that have no consciousness,
Mm.
what would be the purpose of life then? So it's profoundly important. It's something that, in one way or another, I've always had an interest in. I've always been interested in the history of ideas and history of ideas going back to the myths and stories and the religious basis of where the religion come from. It comes from the same question, really. That what is it that's inside us that is the us that is important to us and makes us feel that we're worth maintaining our life. So that to me is the most profound and interesting question in the whole of not only science and the whole of the world. There's, of course, it's not only science that deals with the problem,
Yeah.
deals with the puzzle of consciousness. Lots of literature and art also is around this strange understanding we have of ourselves and our perceptions. So that's always been the puzzle, and I didn't really get interested in trying to figure it out scientifically until over 25 years ago, something like that, I guess. When I wrote a book which called Quantum Evolution. It was published in 2000. I became interested in the idea that quantum mechanics may be involved in life, more generally, not consciousness at this stage, but I thought it might be involved in evolution, and I got in touch with the because I didn't know very much, if anything at all, about quantum mechanics. I got in touch with Jim Al-Khalili, who is a famous broadcaster and physicist, who was at the same university as me, at the University of Surrey, and it was then about evolution and mutation and whether quantum mechanics may be involved in this. And we're still pursuing that at the University of Surrey and unraveling that question of whether quantum mechanics is involved in mutation. But it did get me profoundly interested in the role of quantum mechanics in life more generally. And then I thought, there's a book in there, and I persuaded a publisher to give me an advance to write it, which was called Quantum Evolution. Now, in the book proposal, I had chapter 13, which was reserved for probably the most famous consciousness idea, the idea put forward by Roger Penrose and Stuart Hamerhoff that consciousness can be explained by quantum mechanics, and it's something to do with gravity and gravitational collapse of wave functions. That sounded kind of interesting, and I thought, well, that's a good thing for chapter 13. That was the final chapter of the book, which otherwise looked at things like enzymes and DNA and that kind of thing. So, but chapter 13, I thought, okay, it's consciousness. And then when I started reading it, I knew enough about quantum mechanics at the time to kind of gave me pause and thought, well, actually, what they're proposing, Hamerhoff and Penrose, doesn't work. They propose an interesting idea that structures called microtubules in the brain, which transport neurotransmitters up and down the neurons, that they could be in a quantum mechanical state. And by the time I got to chapter 13 when writing the book, I knew a lot about quantum mechanics, a lot more than I did before I put it down as a topic for chapter 13. And I realized, no, that's not going to work. Microtubules are the busiest structures in the brain. They're always doing stuff. There's no way they could be in a quantum mechanical state. So I wasn't convinced by their story, but reading Roger Penrose's, I then read Roger Penrose's Emperor of the Mind, The Emperor's New Clothes, Roger Penrose's book on consciousness. It'll come to me, the title in a moment. But he convinced me that consciousness is a kind of field. And that's the fundamental idea that goes behind all of field theories of consciousness and my own idea. That when I look out of my window here in the UK, and I see trees, I see wall, I see people moving around, I don't see them as independent things. They're all part of a single structure, which is my conscious mind. And how do you account for that with in science? If we encode information, say in a computer, it's all split down into binary digits, and one binary digit will be there, another one will be over there, and they're all distributed all over the place. And this brings us to the binding problem, which is a famous problem in consciousness, that how is all the information bound up in your brain when matter is divided up into lots of discrete units like atoms and neurons, etc., and biomolecules or microtubules? They're all separate stuff. And information is distributed amongst all of them. So, for example, if I'm looking at the tree which is across the road, facets of the tree, such as the color of the leaves, the color of the bark, the shape of the leaves, the texture, the movement of the branches as they're swaying in the wind, all of those facets are encoded in different parts of our brains, in different neurons, in different areas of the brain. But that's not what it feels like. It feels like our conscious mind is stuck together. It's a single physical entity of which we are at the center of. And how do you make that? And what Roger Penrose proposed in his Emperor of the Mind, or whatever the book is called, something like that, is that it was a field. And what we mean by field is like the gravitational field that holds us, holds me on my seat at the moment. If you're standing up, it holds you to the ground. And the field is everywhere around. It's invisible, it's everywhere. But the field at the sole of your feet, if you're standing on the ground, is an integration of the mass of your body and the mass of the entire planet. That's what's holding you at the soles of your feet to the ground. And that's kind of remarkable. But that's a feature of fields, physical fields, that all of the information is distributed everywhere within the field. It is indivisible. There's no place where the soles of your feet, or the continent of Australia, which is contributing to you being standing at that point, it's everywhere within the field. It's not just in Australia, it's at the soles of your feet as well, that information which provides a little bit of the gravitational force that holds you there. And that's really, I thought, what we needed for consciousness. Penrose thought that. Many people before him have thought that. And when I did more research, it goes back to Gestalt philosophers back in the early part of the 20th century. They also proposed that consciousness was some kind of field. But that kind of fell out of favor when neuroscientists started studying the brain and seeing that, well, you see neurons, you don't see fields, you see neurons, and they communicate by these synapses and neuron firing and all that kind of stuff. And that doesn't involve fields. So the idea that consciousness was some kind of field fell into disuse, if you like. Penrose energized it with his proposal that it was a quantum field. What quantum mechanics does is it turns matter into a field. So if you have an atom of matter that's behaving quantum mechanically, then it doesn't have a fixed position in space, just like the information of the mass of Australia isn't a fixed position in the gravitational field of the Earth. It's everywhere. Well, an atom can be everywhere in quantum mechanics. So quantum mechanics is really a science about fields. So if there was in the brain a quantum mechanical field, then it could account for consciousness. But the problem is in making quantum mechanical fields out of matter is hard. Normally, you have to have a very simple system, an atom or two in a box, cooled down to absolute zero, or as close as you can get to it, in a vacuum, on an optical table, which will remove any vibrations or anything. And when you've got all this, you might retain a quantum mechanical state. Those 2 or 3 atoms can behave as a single entity for, picoseconds or some very short length of time. But that's not going to happen in the brain. So although I was convinced that consciousness is a field, I wasn't convinced that it could be done by a matter field, quantum mechanical matter field. So I looked around for, well, is there any other field in the brain? And of course there is. There's the field that people have been looking at for over a century. Even then, when I was first thinking about it, people knew that the brain generates its own electromagnetic field. And that electromagnetic field is what physicians measure when they put the electrodes on your skull to do an EEG. They've been measuring it for 100 years or more. And mostly they've thought it's just there. It's just a consequence of the brain's activity, but doesn't impact on the brain's activity in any way. It's often described as the steam whistle of a steam train. Generates a whistle, we know about it, you can detect it with the EEG electrode, but it doesn't function in any way. But it occurred to me, well, if consciousness isn't in the matter of the brain, but in the electromagnetic field generated by the brain's activity, then it already has some very interesting properties. For example, it contains all of the information in firing neurons. And that's kind of useful because we've got an awful lot of information in our conscious mind. It's distributed all over the brain, but in the brain's EM field, it's everywhere within the brain's EM field. So that was kind of good. But it also had a very interesting, property, and that's to do with how fields interact. And this, to me, was the key to thinking, wow, this could really be it. At that time, Francis Crick started to work on consciousness, Nobel Prize winners for discovering the structure of its DNA. Before Francis Crick worked on consciousness, working on consciousness as a scientist was like working on fairies. I'm going to study fairies from now on. It was a career destroying move if you said you're going to work on consciousness. Nobody worked on consciousness. It was considered only crackpots worked on consciousness. But then this mega brain, Francis Crick, started to work on consciousness and suddenly became respectable to think about consciousness. So he put a lot of, gave the consciousness field a really big boost. But what he said was the best way to get into studying the brain is, first of all, start with looking at the correlates of consciousness. What that means is when we, for example, I'm always losing my glasses on them. When I take them off and I can't find them and they're somewhere on a very messy desktop, and I'm looking at that desktop and I can't see my glasses, then suddenly I can see them. Now, what happens between the millisecond before I saw them, when I was looking at them, the image of them was on my retina, but I still wasn't seeing them. And then suddenly I can see them. What happens in that few milliseconds between the image entering my retina, being in my brain, being processed, but I'm not seeing them, and when you become consciously aware of my glasses in this case. And what a number of studies have demonstrated in the 1990s mostly and early 2000s is that the best correlate of consciousness is not the neuron firing per se, but when neurons fire in sync. So I'll be nearly there to the end of the where we get to
Continue
on this in a moment. But when they fire in sync, you become conscious. Now that's a bit of a puzzle because neurons process information in independent, the shape of my glasses, the colors of my glasses, all of those features will be processed in independent neurons. They're all firing, but not in sync. And then they get in sync, and suddenly I'm aware of them. Why? They're going through the same neural pathways as we know. But there's a feature of electromagnetic waves which explains it. When electromagnetic waves, like any wave, if they're waving in sync, then they have what's called constructive interference. The signal is amplified because all of the waves, peaks and troughs, match up and you get a bigger signal. It's like two waves in the sea. If they're waving in sync, then you'll get a bigger wave. Whereas if they're waving out of sync, then the wave will be destroyed. So if consciousness is the brain's electromagnetic field, then we would expect it to correlate with synchronously firing neurons. And in the 1990s, that was demonstrated in monkeys and mice, and later in humans. That is the best correlate of consciousness. So it just made sense to me that, okay, all we need to do is switch from the matter of the brain to the electromagnetic field of the brain. You solve the binding problem, all the information is stuck together, and it matches up with the strongest correlate of consciousness, synchronous firing. And it explains why synchronous firing is associated with consciousness. So that was a revelation to me, and that it all made sense. And I thought, well, surely someone must have published about this idea before. And I searched around and no one did. Well, I might as well put a paper or two in, and I did. Submit and had published a couple of papers on this idea. And that was more than 20 years ago now. And mostly it's been not taken seriously for most of those 2 decades or so. But now it's beginning to gain some momentum, partly because of all of the other theories of consciousness have kind of failed to really make progress in understanding the phenomenon. And people saying, well, we need something else. And I think that's what we need. The understanding the brain's EM field is where our conscious mind sits. So a very long explanation that gets us to the beginning of the story.
Yeah. I mean, this is just the very beginning. For all those who are not familiar, let's define it. I mean, you call it the consciousness electromagnetic information theory, field theory, sorry. So the CEMI field theory. Do you want to define that for people who don't know?
Yeah, so it's conscious information because it encodes information. And information, I mean information about the outside world. So this excludes EM fields that generated by toasters and stuff like this, which are not really communicating anything useful about the outside world. So it's information that is from our senses, and that gets from our memory neurons. They get transmitted into the brain's EM field. And what is interesting about the brain's EM field that was discovered more after my first papers on consciousness is that it does influence neuron firing, because if that's all that happened, if it was transmitted, the information is transmitted into the brain's EM field, then who cares? It's there. It's a reflection of the information in the brain, but it's not doing anything. But if the brain's EM field influences neuron firing, then it can have a feedback. Your conscious mind can start pulling on the levers of the neurons, and that's exactly what it's done. It does. Lots of studies, including some more recently in my own lab, have looked at the effect of EM fields on neurons. And neurons are both transmitters of information into the brain's electromagnetic field, but they are also receivers of that information. So it provides a loop of information from the neurons going into the brain's electromagnetic field, where it all gets joined up And there you can start thinking, because that's where your thinking is happening in your conscious mind. And then your thoughts can influence your brain, can pull on the levers of neurons to do the kind of actions that we call our free will.
Mm. That's the fascinating component of this, is that you've taken this complex subject of consciousness, and which is a very deep philosophical question in its own right. And then you've also managed to now approach another topic that people often discuss in various different debates, which is free will. You've managed to tie these two concepts together. And it's interesting because when you first spoke about this, when I first read about it many years ago, I thought about the fact that people think about electromagnetic fields and they talk about it, particularly scientists, in a very mystical manner, you know. So like this is, and this is especially true in medicine. As a doctor, I see it when you talk to another biologist or a doctor, that when you start talking about anything regarding electromagnetic fields, they start to think that you're going down some sort of spiritual, mystical, non-physical realm. Has that been what's been occurring to you as well? Do you feel like your theory is automatically placed in this group of mysticism? And that's not the case. This is still ultimately a physicalist theory, if I'm not mistaken.
Yeah, I think that is a problem. That's one of the reasons why it's taken a while for it to become at least partly accepted, because it is grouped along with the wacky stuff, if you like. Yes, we have crystal therapists who are putting crystals on your body and claiming there's some electromagnetic field coming in and helping to heal you. And people talk about trees having these electromagnetic field auras around them. So it kind of plays into all of that, but it shouldn't.
Yeah.
Electromagnetism is fundamentally scientific. Since the work of Maxwell, who showed that the light that we see is electromagnetism. It's a form of energy that that comes from the sun. It's all electromagnetism. In fact, all of the things that happen on our world, pretty much apart from gravity, are all down to electromagnetism in one way or another. Chemistry is really all electromagnetism. So pretty much everything that happens that we see is about electromagnetic interactions. So it's not spooky at all, but it is not physical. And this is, I think, it's not material. It's not material. And that's the key difference that makes people kind of hesitant about it, because it's invisible. You can't see it. When you look at the brain, you see a big lump of matter and say, well, that's it. That's the brain. That's all that's happening. But there's actually, and a dead brain is not happening anymore, but a live brain has an invisible electromagnetic field, which is just as rich in information as the brain's neurons. But as I said, it has the extra property of all the information being joined up as the information in a single photon or a single electron. It is completely physically united within the brain's electromagnetic field, and thereby binds the information in our conscious mind. So yes, it's a not materialist theory, but it is a physicalist theory. Yes. And that, I think, is, when people say they're materialists, often should really be saying physicalists, because you can't explain our world with just material. You have to, pretty much everything that happens is an interaction between fields. Our current understanding of what matter is, what an atom is, an electron is, they are perturbations of fields, of electromagnetic field, gravitational fields, nuclear forces. They're all perturbations of fields. So ultimately, everything is fields. So this isn't a wacky idea at all. It's no more wacky than a materialist. Just because we can see matter doesn't make it not a field. It really is fundamentally another kind of field.
It reminds me of one of the things you mentioned this earlier as well, but the way you describe meat, and this lump of meat. I mean, when you talk about it that way, it sort of highlights this degree of absurdity. And it almost down and brings your theory back into sort of a normal realm of debate and chat, which is an important way to approach this. But I have noticed that other people also seem to have semi-field theories as well, and some of those do tend to go into the spiritual realms, and I think that's also hindering your own process and your own research.
I agree. There is a lovely story, actually, a short story. You can find it online. you can easily find, by Terry Bison, called "They're Made of Meat." And it's a story of aliens who discover in some far distant galaxy a intelligence and sentience, and they're all excited about this. And then one of the aliens says, "But the strange thing about this sentience is they're made of meat." And they're aghast. "What? You mean that's stuck by a butcher that we eat and chop and make steaks out of? That can't be sentient. That's just nonsense." And then you go on and on and on. And essentially they decide to suppress the idea. It's so bizarre that consciousness could be made of meat. But that is what everyone else thinks. And it is far more bizarre to think that meat can be conscious than it is to think that an electromagnetic field can be conscious. It's much more the latter is much more sensible and realistic and less wacky than the idea a lump of meat is conscious. So, yeah. But yes, you're right. The spiritual stuff, I try to be very rigorous and not get into those deeply philosophical questions about meaning of life and things like this, and panpsychism and all those kind of things, and try to keep to the nuts and bolts of the because I think there is a danger with many fields that they can get corrupted by sloppy thinking, sloppy kind of mystical thinking, and I'd like to keep it very scientifically grounded.
Johnjoe, do you ever worry about the fact that even when people talk about materialist theories of consciousness, so whether it's matter, some sort of a neuronal firing, whether it's a global workspace, whether it's integrated information, people are still going to be concerned that these electromagnetic fields are still merely correlates? And do you think that still satisfies the thirst that some people have for a theory that does not have this correlation issue? Because as we all know, correlation does not equal causation. The infamous.
Yeah, absolutely. We have to take a jump somewhere, but I think we have to make the jump as small as possible, and ultimately we have to come around to the idea that something in our bodies is conscious. Okay, we know that we're conscious, so something is conscious, and that's hugely bizarre. I mean, as we said, we just made them out of meat and blood and bones and all the rest of it, and some part of it is gone. If I told you that your bones were conscious, you'd say, "God, no, crazy." But it's no more crazy than believing the meat of your brain is conscious. So somewhere, because we have our own introspective experience of being aware, that's got to be a property of something in our brain. So we've got to pin it down somewhere. If we pin it on the matter of the brain, we're stuck with the binding problem. How does it get stuck together to give us our experience? If we put it in the brain's electromagnetic field, then that solves that fundamental problem of consciousness and a lot more. It makes sense in lots of different ways that we haven't gone into yet. But it's got to go somewhere, and somewhere we've got to take the wacky leap and say that, okay, this thing that we thought was not aware, not conscious, is conscious. Because otherwise, how are we talking at the moment? Why are we arguing about it? Consciousness is a thing. Awareness is a thing. It's got to be pinned on something. The EM field is the best one.
Johnjoe, some people have new theories of understanding the brain-body connection, and sort of there are these new concepts like embodied cognition, the fact that we have a brain-gut axis, we've got relationships between our body and brain that are separate entities, almost like having two brains in a sense. The fields you're talking about are consistent with the brain. But what does that have to do with sort of serotonin receptors in the gut, other areas of the body? Does this entwine into these?
I don't think it makes any difference from if you believe consciousness is matter of the brain, or consciousness is the EM field of the brain, then we still have, it doesn't differentiate between the two theories in terms of whether there's a wider consciousness in say the gut or anywhere else. I don't think you need to I mean, I'm a donor, a kidney donor. I gave my wife my kidney,
Oh, okay.
so
That's
her kidneys were failing.
very
I
romantic.
don't think I passed any of my consciousness to her when I gave her a kidney. She has not got. She doesn't. Still doesn't like the things I like to eat. She doesn't like the music I like. So I don't think. Yes, there is nothing about the embodied consciousness and things like that which convinces me that anything outside the brain needs to be conscious, because we all of those areas that we think we are embodied in the rest of our body and in our gut axis and all the rest of it, they're all connected via neurons to the brain. So the information is in the brain. You don't need to have a consciousness elsewhere. And I think there's absolutely zero evidence for it. There's not any kidneys, there's hearts and other organs that are being transferred from one person to another. And there's no evidence at all that any consciousness is transferred in that operation.
Tell me, Johnjoe, do you know of any are there any papers out there that sort of describe EM fields anywhere else in the body?
Well, there's lots of them, yeah. A heart, for example, we use ECG to detect heart arrhythmias.
I didn't ask the question correctly. What I wanted to know is do you know if there's any sort of relationship between the EM fields that we do have in the body that link up to sort of the EM fields generated by the brain? Connections there?
I don't know if you've. I think you have. I think I looked on your podcast. You've interviewed Mike Levin.
Yes.
Yeah. Okay.
We've actually chatted a few times. Yes.
Yeah. No, fascinating work. Him and Wendy Bean.
Such amazing work.
And I think it's the prehistory of consciousness, the kind of thing that he's looking at. It's that he is already finding that the EM fields generated by the body have causal efficacy. They are doing things to help in wound healing, in development, and those kind of things. That, to me, is the prehistory of what's happening in our brain. That the EM fields that were generated by the brain started in evolutionary history to make a difference to how the brain works. And instead of having an influence on wound healing or development, they had an influence on our actions. And that just seems to me a natural consequence of the kind of thing that Mike and Wendy and other people have found in the role of EM fields in other parts of our body. Once you have EM fields in the brain, then they are in the powerhouse. They are in the control room now, and they can start doing all sorts of things like making you happy, sad, making you do actions, preventing you from doing actions. Suddenly, the EM fields are not just involved in development or wound healing; they're involved in everything, every action that you do.
Mike actually might watch this episode because he just sent me an email the other day to say he watched a previous episode. So I want to almost speak for him in the sense by saying, I mean, what he's trying to show at some point is that there's bioelectricity. I mean, there's electricity, electrical signals can communicate messages, which is something we never really thought was a thing.
Yeah.
And this is amazing work. I mean, he's showing how information can be transferred in ways that we could never imagine, and the impact this has. Do you think at some point all of those bioelectrical signals could perhaps create an EM field for the entire body that sort of communicates all together?
Well, although the brain's EM field is everywhere, obviously we know that if you have a transmitter very far away from you, it is less likely to be detected by your radio. You know, I can detect the times when it was all radio signals. You can detect, London, say, but I couldn't detect Edinburgh. And very occasionally you might detect somewhere like Moscow or something like that on your radio, but very rarely. And that's because the strength of the signal decreases with the cube of the distance, is it? I can never remember my physics. Either the square or the cube of the different distance. So the strength of the signal drops. So yes, the information, there will be some bit of information that, say, comes from your toe, that when it's injured, that will also impact the brain. But most of what the brain is doing is going to be influenced by the nearby EM fields, which are generated by neurons, particularly as neurons are the most electrically excitable are the biggest transmitters of signals and the most effective antennae for signals as well. So I would say yes, it's possible, but I think the influence is likely to go down the further and further away the organ is from the brain.
Yeah, and perhaps even the myelination might also play a role, because that's much more common within the brain.
Yeah, but I'd be interested in Mike's view on this, and Mike quite well, and we've discussed this.
We're going to chat this. We're going to chat about it soon. So
good.
When we have that other chat, I'm going to make a note to actually ask him about this.
Yeah. Okay.
You touched on something just now, and I have a note here. Let me just find it. You said at some point, I mean, when someone's alive, they can have this field, and then you said, well, unless they're dead. I mean, but sometimes when someone dies, you sort of still see an electromagnetic field around them. There's still some sort of information being carried. So what happens when someone really dies? Does the information store somewhere within the field, or is this?
Well, remember that the information is constantly changing in your brain. It's not like a hard disk of a computer that would be laid down forever. We do have memories that are in the synapse, or we believe memory is still one of the mysterious things about how our brain works, and we don't fully understand it. But most guesses are that it's maintained in the synaptic connections of our brain. Mm-hmm. Those will be still there when we die, but they will start to disintegrate.
Yeah.
So they won't last long. There is another interesting way of thinking about it, and I've not really thought this. This is now when I go into dangerous, wacky kind of area. But
it's fine. This is an open space. This podcast is exactly what it is.
But there is something that I think, wonder what that means. But okay, information. According to quantum mechanics, information can't be created or destroyed. It's just moved around. Mm-hmm. So there's a conservation of information. It's a theorem, or what is that what they call it? A theorem? No one's proved it as far as I know, but it's fundamental to quantum mechanics that information can't be destroyed. Now, the brain's information, what the CEMI Field Theory says is the brain's information has the quality of awareness. Okay? That's what is aware. The information encoded in the brain's EM field is aware. Okay, so then I have to go on, look at that more deeply. I have to say, okay, well, is all electromagnetic field information aware? I say, well, what can the electromagnetic field of a single electron know? All it knows is itself. It doesn't carry information about the outside world. What is novel and interesting about the brain is that the brain's EM field carries this vast amount of information about the outside world and the inner world of the person, their memories and everything else. It's all encoded in the brain. So it's a much richer source of information. But it is information, and it's never going to be destroyed according to quantum mechanics. So what happens? I don't know. I mean, every thought that we make is transmitted into the brain's EM field, and some of that leaks into the universe. So what is that information? It's not connected in the same way, but it's still there. As I said, EM fields unified. There's only a single EM field for the entire universe. The universe has a single EM field, of which our electromagnetic field is part of. So when we stop thinking, when our brain stops working, do we become part of the universe's electromagnetic field? Do we get any awareness of that state? I don't know. I will find out. not for a while, I hope.
Oh, hopefully not. I was just going to say, hopefully not too soon.
It is a kind of spooky, kind of interesting idea. The conservation of information is if information, electromagnetic field information, has the property of awareness, and that's fundamental to CEMI Field Theory, that's the only way we can account for consciousness, then that information that's gone off into the universe, every thought that we've had, still has that property. What does that mean? I don't know.
It's crazy, because when I remember when I first, this was years ago, when I came across your work and Jim Al-Khalili, I watched one of his, I think it was a TED talk, if I recall, talking about quantum biology, and then I went down this rabbit hole. learning about it, reading about it, then came across your work. I remember still back then being so fundamentally materialist that to me it sounded completely absurd. And since starting this podcast, the more I've learned about other theories and understanding other people's perceptions, the way they work, it becomes a lot easier to empathize and sort of see the other person's viewpoint a lot clearer. And but then you also don't know where to draw the line anymore, because at this point, as we're discussing this, it's easy to see how we can tread down territories that are non-scientific. We can almost go into some sort of bizarre phenomenon that, I mean, it's not a bad thing necessarily. This is still very intriguing things. And it's not to say that the work is wacky. It still is quite cool that you can go down these routes, I think.
Yeah, I think to me the line is when it's no longer science. So when it's and when it becomes no longer when you can't actually prove what you're speculating about, it is no longer science. So people ask me, well, how do we know that the radio isn't conscious? And I would say, how would you ever prove it was or wasn't conscious? And until someone comes up with a way of answering that question, then I don't think there's any. That is part of science. We just have to say, well, as far as we know, the radio or my car or whatever isn't conscious. Maybe someday it will start talking to me, and I'll disprove that theory. But until then, I'm going to take the default, simplest way of accounting for the fact that my car doesn't talk to me, that it is not conscious. Yeah. And I think we have to take the ideas that I was just saying about what happens to our consciousness after death. I don't think I'll ever be able to test that. So, I mean, look, so I count that as non-scientific speculation, which is perfectly okay as long as we don't think it's science.
Yeah,
we can speculate. Philosophers have been doing it for centuries, and they got away with it. Why shouldn't scientists occasionally get away with a bit of speculation?
I can just see the way someone could take this information and sort of a patient maybe in a psych ward listening to this conversation now realizing that actually no, the radio really did say that to me.
Exactly. It has spoken to me. Yes.
That's why I always have to put a disclaimer for the podcast. I mean, this is just for informational purposes only. This is not, okay, as a doctor, I don't want patients to really go around thinking, okay, this is fine. This is purely educational. This is just a disclaimer for everyone. But tell me, the brain, the skull acts as almost a Faraday cage, holds in all these signals as much as possible, the fields at least. So it can't go too far. I mean, you briefly touched on that fact. I mean, it's not like you and I could step together side by side and sort of do almost a telepathic communication with each other. That's not what you're saying either.
No, I have a lot of people who ask me, and whenever I give a talk in this, someone always pops up and says, "Does it explain telepathy?" And I say, "No." No, it doesn't. Because firstly, is telepathy a thing that can be explained by science? No, because no one's ever done a scientific experiment that's actually demonstrated telepathy. So it's like saying, does your theory explain aliens on the moon? No, because there's no need to explain them. So there's no evidence for telepathy, and all the scientific tests have shown nothing's there. But we wouldn't expect it from my theory.
You can see the headlines now: CEMI Field and the Fermi paradox. I mean,
yes. And no, I don't think. Telepathy can't be explained by CEMI Field Theory because of that problem of the information is diluted as it goes further and further away from you, and also your brain has developed. It's like going back to Levin's work. Your brain has developed to both make its own fields, own EM fields, and decode those fields. I doubt if any other brain is capable of decoding them. It's probably only...
Oh, Johnjoe, I think I've lost you there.
ASCII in the brain. There's no fundamental code that all brains use. They're going to be using all different codes. So I think only your brain can decode the EM field information inside your head.
Sorry, Johnjoe, for a moment there I lost you, but you're back.
Okay.
As long as you're back, it's great.
Okay, it's an EM field.
I was just about the same thing.
I could switch to another. I can see. I should have made. to prevent it happening again, I could switch to another router.
It's fine. We'll give it a go. If it fails again, we'll switch over.
Okay, we'll leave it as it is.
While we're on that topic, though, I mean, what are the chances of other sort of electromagnetic fields interacting with ours anyway, not causing sort of telepathic communication, but actually affecting my own EM field?
Yeah. People have concerns about this in terms of whether, electrical installations, telegraph wires, and stuff like this could influence how we think. It's feasible, I would say, if a very strong electromagnetic, if an electromagnetic field can make a radio talk, as it can when we have a radio receiver, it could interfere with the brain. But it's working on different frequencies. It's not going to be decodable. So by the brain is designed by evolution and development to decode its own information, not to decode the stuff that comes in the radio waves. And as far as I know, no one has ever managed to listen to a radio station just with their head. So we can't decode that information. Whether it can do any harm to us, I think the evidence is very slight, if any, that there is any influence of power stations and stuff like that near us doing any harm. So my guess is not, but because there's been a lot of research and a lot of it contradictory in this area of whether external EM fields can cause ill effects in people, I prefer to stay agnostic about it, as I haven't really studied the literature enough to be very clear in my own mind about it.
I think it's fascinating because you're discussing a theory that is so quote unquote wacky, but it's not. And yet you simultaneously write a book that's like Life is Simple and talk about Occam's razor. I mean, William of Occam, and you discuss how you approach science in a very scientific manner because of the fact that you understand the difference between taking a leap of faith and being agnostic when agnosticism is needed. So I just want to put that out there for you to sort of.
I think the as you said, in my recent book, Life is Simple, I make the case that what differentiates science from other forms of ways of making sense of the world is that science is committed to take the simplest solution to problems. To me, the simplest solution to consciousness is the brain's electromagnetic field. It solves so many problems, such as why synchronous firing should be correlated with consciousness. It gives us a way of understanding one of the other big puzzles of the brain, why most of what the brain does is actually non-conscious. And that's something we have to also explain, because if the brain is just neural activity, then why isn't most of what the brain does conscious? We do a lot of very complicated stuff. A lot of people have argued, well, it's only the really difficult stuff that we do that we need our conscious mind. No, we could be solving a really difficult equation and still stand on our toe, and we become highly aware of a very simple stimulus of someone standing on our toe. So very simple stimuli can overwhelm our conscious mind. So complexity and consciousness aren't necessarily related, and yet we have to explain how some parts of or some of the things that our brain does is we're not aware of, like me waving my hands around when I talk. I'm not aware of that. And lots of things that we do, blinking and all this kind of stuff, that's all done non-consciously. So we have to explain how the brain can work in two different ways, one a conscious way and one a non-conscious way. As far as I'm aware, the only consciousness theory that really sorts this out is the CEMI Field Theory and other EM field theories of consciousness, that says only the activity from synchronously firing neurons, because the waves of the synchronously firing neurons fire together, only that gets transmitted into the brain's electromagnetic field. If neurons fire asynchronously, and mostly they do, that information doesn't get transmitted into the brain's electromagnetic field, because the top of a wave of one neuron is cancelled out by the bottom of the wave of the other neuron. So it explains why only some information is consciousness. It's only the synchronously firing neurons, and that's exactly what we find. The rest of what the brain does is going to be non-conscious. So you get a conscious and a non-conscious mind. So all of those problems are just disappear once you just move consciousness from the matter of the brain into the brain's EM field. And I think it's a much simpler theory than others like IIT, which is integrated information theory, which has to propose this massively difficult mathematical equation is what explains consciousness. And you know,
a level of
cleverest physicists can't solve this equation for more than 2 or 3 neurons at most. And I just can't see that it's needed. So it's a simplest theory. It's and I admire that in science, and science has been driven by simplicity right from those early days. As you mentioned, William of Occam was the first modern person to make that claim that science is all about simplicity, and it has stood the test of time. Higgs boson was predicted on simplicity grounds. There were more complex theories, but the simplest was the Higgs theory that predicted the existence of the Higgs boson, and only one of them was the simplest of many theories to predict. One of them, the only advantage of the one that predicted only a single Higgs boson, well, it was simpler than the others, and that's the way it turned out. So science looks for simple solutions. Semi-field theory is, in my view, far simpler than any other theory that attempts to account for consciousness.
As of mid-2024, are there any sort of labs, other people's work that you're looking to that are sort of showing support for this theory? How's the evidence looking for this theory, and anything new, any updates for people?
Well, yeah, there was work in I'd have to. My brain is useless at digging out names and particular studies. But there was a very interesting study.
At least tell us about the studies. I'll
okay. Yeah, sure. And I can send you the reference later if you want. There was a very fascinating study done by a group at MIT, and what they did was look at the brain neurons in the brain of monkeys, I think it was, that was recorded by multi-electrode recordings of the brain when they were keeping something in memory. Okay, and there's lots of studies have done this, and they've found that if the monkey is thinking banana, say, okay, when it recalls banana, different sets of neurons will fire. And there's a name for this, and again, this has escaped me at the moment. It'll come to me sometime. It's that memories seem to not rely on particular neurons. A set of neurons will fire, but it won't be the same set of neurons when a monkey thinks of the banana 2 or 3 times. It'll be different neurons. It'll be 5 or 6 neurons, say, that will fire, but it'll be a different set of neurons. And that's very hard to explain in terms of memory when we think of memory in the synaptic idea of memory that I mentioned earlier, that it's to do with just the connections between neurons via synapses. Temporal drift, I think it is called, that the encoding of a memory drifts between different neurons. But what this study at MIT showed is that what was preserved wasn't the neurons, but the electromagnetic field generated by those neurons. So although different
the patterns of the electromagnetic fields just similar.
Yeah, the electromagnetic field of the neurons was always similar. So in other words, the memory of the banana was not encoded in neurons. It's encoded in the electromagnetic field generated by neurons. And that was a very fascinating study that I think could be very interesting. The other big area that I think, if anyone is listening who wants to try to make, I think it would be fascinating to make, and I think someone's going to do it, and I think it should be done despite people having fears about it, a conscious AI. That's got to be the way that things are going. You've got to make, at the moment we know ChatGPT is fantastic, it does wonderful things, it's not conscious. We still haven't got, with conventional computing power, we haven't got any closer to consciousness. There's no inkling, there's not even the kind of consciousness that a little baby will have as soon as it's born. That's not, no little baby is starting to come gurgle, 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 and be, oh, I'm pleased to see you, do spontaneous stuff like that. So despite the fact that modern computers are now competitive with the power of the human brain, but there's no spark of consciousness there at all. The reason for that, of course, according to the CEMI Field Theory, is that all the conventional computers do is simulate what the non-conscious brain is doing, calculating and computing with the wires. That's what we've said the non-conscious part of our brain does. But then the conscious stuff, what the information that goes through the brain's electromagnetic field, is where consciousness is, and that's where we do our conscious thinking. And that's where our creative thinking, that's when we come up with great ideas. We don't come up with them, or we rarely, sometimes we do. Our non-conscious mind seems to be able to generate good ideas, but mostly we use our conscious mind to think and to come up with good ideas. That is lacking in computers because engineers, they call it electrical interference, EMF interference. When they build computers, they engineer them to not be influenced by their own electromagnetic fields. So they've engineered out consciousness in computers. That's happened because that's the way all electrical devices work. They don't want them to be interfered with by their own electrical activity. There's a fascinating experiment that was done over 2 decades ago. Well, it's done when I was first writing. Yes, over 2 decades ago. By a chap called Andrew Thompson at the COGS group, Cognitive Science Group at the University of Sussex in Brighton. And this work is, I think, one of the most fascinating experiments I've done, and no one's really picked it up and gone forward with it. And I've tried myself to get funding to do work on it, but not taking it forward. So Andrew Thompson did an experiment of making an AI. This was a long time ago, with more than 20 years ago, but not designing it, evolving it. So he took something called an FPGA chip, field programmable gate array. And what these are a chip that can be reconfigured. The electrical connections can be reconfigured endlessly, so you can make lots of different configurations. So we took a number of them, let's say 100 of them, and randomly set them to different configurations, and then tested each one for their ability to solve a task. And he gave it a simple task. I think it was recognizing a musical note. And they're all rubbish at it, but maybe 1 or 2 were a little bit good at it, could do it just slightly better than what would be expected from a random guess. So he took the best one, and then cloned it across the entire 100, and then mutated them all a bit. Okay, and then repeated the exercise, and then did it again and again and again for, I think, about 100 generations, until he got a chip that worked. It could now recognize the musical note. So he had evolved an intelligence that could do this task rather than designing it. But it was weird. There was one feature of it that was particularly puzzling. It didn't work all the time. Sometimes it did, sometimes it didn't. And they worked out eventually what was the factor. It only worked when the radio was on in the lab. Now, why would that be? Because this was an off-piste experiment that they weren't paid to work on. It was something they thought would be fun to do. So they did it at the end of the day when they'd finished the normal work, as it goes into the evening, and turned the radio on to keep themselves company. And they evolved the chip with the radio being on. So it was picking up radio waves and using them as part of its computation. And it needed those radio waves, EM fields, to actually do the computation. And that was one weird thing. The other weird thing about these chips were that there were some parts of the chip, it's a complex microchip. It's got lots of little circuits and resistors and capacitors here and there. There were some parts of it that were necessary for the computation. If they removed those completely, it didn't work. But they weren't connected to either the inputs or the outputs. So how do you explain that?
Okay.
The only way to explain it is that they're communicating through EM fields. So EM fields are within the chip are communicating with each other with different parts of the circuit. And also in that experience, they actually were picking up signals from the radio as well for the computation. So the fascinating conclusion of that is if you evolve an electrical circuit to do a task rather than design it, you involve an EM field sensitive computer, one that computes through fields as well as through standard electrical standard electrical connections. I think that has to be built on,
Uh,
and we have to build an AI that does this.
And that also
And it's
begs
often,
the question then,
yeah,
Johnjoe. I mean, at what point were our EM fields generating this sort of potential in terms of our evolutionary journey?
a
And
very interesting question. Certainly, somewhere, my guess is that the brain went through the same process that Andrew Thompson's experiment did. At some point, it started to, communicating. First of all, the neural communication was all non-conscious. All of the information was sent down the wires. But then, as more and more neurons got packed into the brain, then it started generating, and many of them were often synchronously firing. It started to generate its own electromagnetic field. And then those electromagnetic fields, and this has been demonstrated experimentally, EM fields of the strength and structure of the brain's EM field, if you, we've done experiments in our lab, if you apply them to brain tissue, that brain tissue will twitch, if you like. There is a feedback onto neurons. Neurons are sensitive to the brain's electromagnetic field. Now, once that happens, then the actions driven by that brain are going to be visible to natural selection. So natural selection, acting on a brain that's now got electrical interference, will do two things. If the electrical interference is bad for us, then it will insulate it. It will insulate those things. It will dampen down those electromagnetic fields. It will make them fire asynchronously or whatever, get rid of that interference. So part of the brain will evolve in the direction of being non-conscious, because things you don't want to interfere with your conscious mind, like the heart beating or walking or breathing, all of that stuff needs to be non-interferable. Mm-hmm. But if there was some capacity that was captured by electromagnetic field interactions between neurons, then natural selection will kick in to develop that. And my guess that has happened certainly by the time of primates, probably somewhere in mammalian evolution, maybe way back in vertebrate evolution, that take a gradual takeover of electromagnetic fields in terms of driving actions was selected by natural selection as being an efficient way of dealing with complex situations by thinking rather than just automatically responding. And certainly primates have it. My guess is higher mammals like dogs and cats also have it. But those are all guesses. Until we really understand and can prove what consciousness is, it will be speculative. But somewhere less than humans, I'm sure, has awareness and consciousness like us. But it's a very like us, but probably not very much like us. Can you think of how you would think without language? Yeah. That's a tricky thing, isn't it? How you would think without language. Certainly we do. We get kind of feelings and stuff. And that's what I guess animals are thinking. They don't have language, so they think in terms of feelings. Those can't be very complex calculations and ideas that they can have, I guess. They see food and say, oh, I'd like to be over there near that food. And that's a feeling rather than in our mind where we can encapsulate the feelings in words as well and start to compute with them by starting to think through problems. And I don't think animals have that capability.
It's funny that you mentioned that. I just today, I think earlier, was reading a paper, I can't remember by who, but it was on orcas, and apparently they're starting to figure out a communication system that seems to be very much structured.
Okay.
I'm not too sure on the detail. I just briefly came across this while I was at work reading, and that seems fascinating to me, because you're right, linguistics, language, this triumph in evolution that sort of allows us to shape our views, shape our thoughts, and sort of give the synchronicity that's required to give attention to certain things, changed the game for humans. This seems to be one of those game changers, I think. So it would be fascinating to know, do these orcas speak a specific type of language, because then this gives them a sort of different EM field in that sense.
Yeah, I think the experiments could be done, and once you commit yourself to the idea that consciousness is the brain's EM field, the key question is, does the EM field generated by a brain influence its own actions? And that's something that can be answered. You can imagine experiments that will then determine what percentage of brain activity in a particular animal is influenced by the animal's brain's EM field. That would be a measure of consciousness if we could do that kind of measurement. I don't know how we'll do it at the moment, but I'm sure it will be possible to do that at some stage and find out how much animals are thinking consciously.
Would you say this would be taken further with regards to free will? At what point are they making active decisions to either go left or right in terms of how much?
Yeah, well, that does the other thing that CEMI Field Theory provides is a theory of free will, and provides it for free because it divides the brain's activity into those which are non-conscious and those which are conscious. We call our conscious decision making those which aren't made by the automatic part of our brain. We call it free will when we make conscious decisions to raise my hand or not to raise my hand. All of those are driven by our conscious mind. So I think everyone gets into a muddle with free will because of the word free. I think we have to stick to what the second word, which is will. Will is when our conscious mind is willing our actions. It's not necessarily free because it's all determinism ultimately in science. Jumping out of determinism is very difficult. So it's still deterministic, but our conscious actions are those that are driven by our conscious mind rather than our non-conscious mind. And that gives you a nice, simple explanation of free will. It doesn't require anything deep or philosophical. It's just the stuff driven by our conscious mind, the brain's EM field rather than the neurons.
Yeah, so it's sort of just a byproduct of being conscious in itself. So
yes.
just jumps along for the ride.
yeah. Once the brain becomes conscious by having an EM field, then those EM fields influence actions. We call that free will. I mean, if people say, you know, as I said, the word free causes a lot of confusion here. Say, if you think about what we believe our minds are doing when we make purposeful actions, we don't necessarily think that we're without a preceding thought. When I think, okay, I'm going to phone my brother, it may be because I've seen something on the TV that's reminded of him. I won't think that idea will just pop into my head without any precedent. And I think most of what we do, if we think hard about every action that we do, it's preceded by some other thought. So I don't think determinism is the problem of consciousness. It's never been. And in the past, people didn't think of it as being non-deterministic. They talked about fate, that your actions will be driven by fate, not by, and fate was something you had no control over. So the idea of determinism, of being free will being something, or will being free, something that isn't determined by anything that's happened before, comes out of later thought in philosophy and Christianity, where you had to be punished for your sins. So that's really the source of where the idea of free will comes from. But if we just accept that there are some thoughts there's some of our actions that are driven by our automatic brain and some that are driven by conscious mind, and that makes a lot of sense, and it's predicted by the CEMI Field Theory, and then you don't need to worry about the philosophy.
We touched on a species going from let's say amoeba to humans, and obviously maybe vertebrates have this, perhaps mammals have this. What about humans? What about when we start off as embryos working our way upward into adulthood from childhood? When does this become active?
And your guess would be as good as mine. I don't really have any insight. The key thing is that when the brain's EM field influences the activities that a person is performing, and I think that's when they become less than more than reactions. So, you know, blinking is a reaction. If a fly flies into your eye, you will blink, and you've got no control over it. Then you can see a baby, you know, might look this way and that way, and it will do the kind of pause and look at things, and you can be pretty sure there's some thinking going on in that baby's brain once they start toddling around and moving around, and they laugh and stuff like that. And funny enough, hardly any animals laugh. People say that some monkeys laugh, but so they can laugh at themselves and they can find things amusing. All of those things are conscious things. We couldn't we wouldn't find anything amusing non-consciously, for example. So I think you have to ask the question, what do we need our conscious mind for, and what can we do without our conscious mind? I can do all this moving around in my hands non-consciously. I can drive a car pretty well non-consciously. I mean, we know that if we have an accident, as everyone does now and again, and you think, what was I doing a moment before? You'll probably not be able to remember, because all emotions that you're doing are going on non-consciously. So there's lots of things that we do non-consciously. Then there's stuff like, a long division we couldn't do non-consciously. And there's another interesting feature of consciousness, that is, you can only do one thing at once, really. And that's strange, because you can do lots of things non-consciously, like me waving my hands around. I could be scratching my head and moving my arms, and I could be tapping a tune. All of these things are going on. But you can't, say, do a crossword and talk to someone at the same time, could you? So your conscious mind is this has been established outside of the CEMI Field Theory, but your conscious mind is what's called a serial computer. It can only do one thing at a time. Whereas your non-conscious mind is a parallel computer. It can solve lots of problems and be working on lots of problems simultaneously. So again, you've got to account for that in the brain. CEMI Field Theory does it like that. It's no problem. There's only a single brainium field. Unlike the neurons, which are distributed, and there's lots of different circuits, lots of different areas, the brainstem field, from its perspective, is singular. So it's always going to be only one thing at a time. Anything else will start to cause interference. So it's identifying the things that we do consciously. And certainly we couldn't imagine talking non-consciously. You couldn't have a conversation with someone non-consciously. You couldn't do anything creative non-consciously. So all of those things that we require our conscious mind for, when we see those happening in, say, babies or in animals, then we've got to admit that they are very likely also conscious.
Johnjoe, where do you see the future of CEMI Field Theory going? What would you like to be done in terms of other people who watch this podcast, the thousands of people listening? Where do you want some of these future scientists to take this and perhaps?
Yeah, I think we have to take the brainstem field seriously and find out how it functions as a conduit for information transfer in the brain. No one's really done that. I mean, there's no one's even worked out how you can calculate how the EM field generated by the brain will influence neural firing patterns. All of those things need to be calculated. We need to do a lot more experiments on how neurons can communicate through electromagnetic fields. And we're doing some of those experiments in our lab by applying external electromagnetic fields, but it's tiny, the amount of work that's going on in this kind of area compared to what's going on in other areas of neurobiology. And I think we need to try to use these principles to make a conscious AI. Ultimately, I think the only way that you will prove a theory of consciousness is by applying it to make a conscious AI. And the kind of work that I was describing earlier gives you a route towards doing that. There are lots of other theories which will also give you a route towards doing that, like IIT. According to IIT, computers are already conscious. So to me, that's already disproved IIT. Global workspace is also been disproved, because computers can have global workspaces in the global workspace sense, and none of them have shown any signs of consciousness. So we've got to wake up and kind of say, okay, well, let's try to design a conscious mind based on different principles, on, say, IIT or global workspace or CEMI Field Theory, and let's see which ones talks back to us.
So would the goal then be to create this artificial intelligence to match our electromagnetic field? Or?
I think it's more than artificial intelligence. It's a conscious artificial intelligence. There are, of course, ethical issues there, and those have to be looked at as well. But there are ethical issues with making any conscious being.
I mean, either way, everyone's trying to do this. I think it's an inevitability at this point.
Yeah, there is an inevitability about it. And every time we have a baby, we make another conscious being. So why not make one in
that turn out to be a murderer and still go around and kill people. So
exactly. We can't predict what biological conscious beings will do. But I think the advantage of it would be that we would be able to understand consciousness better. And, going way into the future, we can think about the possibility of transferring our minds to an AI that's much more durable than these bodies are sadly going to decay in not so many decades. So, there are those kind of sci-fi ways of preserving humanity, and I think we will need them in the future.
That makes it quite exciting to know that. I mean, because fields obviously throughout the universe. I mean, we could in some way be completely other side of the universe if the tech becomes
absolutely. If we can transfer our minds into an AI, then we could travel a lot easier to travel at sublight speeds to really explore the universe. And then the question, of course, you mentioned the Fermi paradox. Why haven't we already met the aliens who have gone through this stage and developed the very durable forms of themselves? I mean, if a consciousness is an electromagnetic field, could you transmit it?
Yeah.
So you wouldn't even need a spaceship. You could send a big beam of electromagnetic information across the universe. There are all sorts of sci-fi ideas that are so exciting and interesting, bizarre and speculative, that we've got to go and find out what there is there. And if you take the idea that consciousness is an electromagnetic field, then all sorts of interesting stuff starts to emerge from that idea.
It's completely fascinating, and it's super exciting to see so many different theories of consciousness, people taking leaps, people doing such great work. Thanks to you. Any final words, anything you want to say or add? Do you think there's anything about CEMI Field Theory that people might have misunderstood from this conversation, or things you've always wanted to point out?
No, I just think that thinking that our mind is an electromagnetic field, an invisible form of energy in our brain, is, I think, interesting, fascinating, and it feels better to me than to think my mind is a lump of meat. I think if everyone starts to think of themselves as this entity of energy that is driving their brain, of electromagnetic energy, pulling the levers of the brain, I think it just gives a different feel of what we think we are, and it makes so much sense, and it gives us lots of speculative ideas that we can take forward in terms of thinking about what happens after death and all that kind of stuff. We're never going to know until we get there, but we can speculate nevertheless.
And speculation is exactly what this podcast is about, because although I call it mind-body solution, I don't claim to have the solution, nor do I think we'll find it, but hopefully one day it's possible.
Absolutely. You've got to have
times.
Yeah, as I say, you've got to have an open mind, but not so much your brain drops out.
Yeah, I would say be passionately curious, but reasonably skeptical at the same time.
Absolutely. You've got to be rigorous. If you want to do science, you've got to be rigorous. You can still speculate, as long as you label it as speculation and we can't prove this or that, but speculation is fine because it can inspire people to study science, and it can inspire people to do things that lots of speculations have turned out to be true. So it's okay to speculate as long as we know that's what they are.
I mean, just look at how much science fiction has become reality at this point. It's
exactly.
Phenomenal.
Exactly. Indeed.
Any final words, Johnjoe? Thank you so much. This has been such an...
Well, thank you for talking to me, Tevin. And anyone who wants to get in touch with me, and if they've got any great ideas how to test CEMI Field Theory, and certainly if anyone wants to make an artificial AI and has the resources to do it, get in touch.